Chapter 4. Differentiation of functions of several variables. Introduction. Chapter 4 covers the concept of partial derivatives and their applications. Partial derivatives allow us to calculate the rate of change of a function with respect to each independent variable. This chapter explores the calculation of partial derivatives for functions of two or more variables, as well as higher-order derivatives. It also introduces the concept of partial differential equations. Learning objectives. By the end of this chapter, you should be able to 1. Calculate the partial derivatives of a function of two variables. 2. Calculate the partial derivatives of a function of more than two variables. 3. Determine the higher-order derivatives of a function of two variables. 4. Explain the meaning of a partial differential equation and give an example. Key points. Partial derivatives measure the rate of change of a function with respect to each independent variable. The partial derivative with respect to x is calculated by taking the limit as h approaches 0 of a difference quotient. The partial derivative with respect to y is calculated by taking the limit as k approaches 0 of a difference quotient. Higher-order derivatives can be calculated by taking the partial derivatives of the partial derivatives. Partial differential equations involve derivatives of a function with respect to multiple variables. Real-world application. Partial derivatives have numerous real-world applications, particularly in fields such as physics, engineering, and economics. For example, in physics, partial derivatives are used to calculate rates of change in multivariable systems, such as the rate of change of temperature with respect to time and position in a heat transfer problem. In engineering, partial derivatives are used to analyze the behavior of complex systems, such as the flow of fluids in pipes or the structural stability of buildings. In economics, partial derivatives are used to model and optimize production and consumption decisions, such as determining the optimal level of production given various input costs. Conclusion. Chapter 4 introduces the concept of partial derivatives and their applications in the differentiation of functions of several variables. By understanding how to calculate partial derivatives and higher-order derivatives, you will be able to analyze the rate of change of functions with respect to each independent variable. This knowledge has practical applications in various fields, including physics, engineering, and economics. Additionally, the concept of partial differential equations provides a framework for solving complex problems involving multiple variables. By mastering the techniques and concepts covered in this chapter, you will be equipped to tackle a wide range of real-world problems that involve functions of several variables.